Geometry Regents series. This is going to be questions 13 through 18. Now, if you're looking at this problem, and hopefully you're like, anyone can do this problem. It's true. Anyone can do this problem. If it just asks you what transformation took place. I mean, I think we know the level. This is level 1. We're talking about transformations here, right? And I really don't know what to talk about here. It's just kind of like, bruh, that's a rotation, you know? It's like, come on. And if you don't know that, then I don't know what to tell you. Yeah, that's clearly a rotation. Okay, let's keep moving. Next one, 14. In the diagram below, triangle DEF is the image of triangle ABC after a clockwise rotation of 180 degrees in a dilation where AB equals 3, yada, yada, yada. Which relationship must always be true? Now, you might be looking at this and saying like, oh, this is level 1. This is like all this transformation stuff. But really, in my opinion, this is more like a level 3 question. All right, and I'll tell you why in a second. This is about similarity and the properties we know about similarity. Now, similar triangles, you remember there's 2 key facts, okay? In similar triangles, or any figures for that matter. 1, we know the ratios of the corresponding sides must be the same, right? And if you look here, the ratios are all the same. 11 to 5.5, that's a ratio of 2. 9 to 4.5 is a ratio of 2. 6 to 3 is a ratio of 2. So the ratios of all the sides are the same, and that's true when you dilate something. All those ratios will be the same. And 2, we know angle measures are preserved. All right, so when you dilate, the angle measures stay the same, all right? And the angles will be the same between the 2 figures. So if we're looking at this, right, let's erase all this business right now. What we know here is that angle A is congruent to angle D. And remember, we know that because these are in the same position. Hold on, sorry, that's just getting a little messy. We know angle B is congruent to angle E. All right, and that's also because they're in the same position. And we know angle C is congruent to angle F. All right, and that's all we know. We just know that the angles are congruent, all right, in similar triangles. So if you look at this, it says the ratio of A to D is 1 to 2. And the implication there is that the angle got twice as large, right? And that's not true at all, right? The angle stayed the same, so that's out. Take this one, that's bad. Now, the next one says that C to F is also a ratio of 2 to 1, and that's also, once again, assuming that the ratio of the angles, the size of the angle doubled, which it did not. So then we just have to look at these next ones. And this one says the ratio of A to C is the same as F to D. Well, let's see. Does A match up with F? No, so that's not probably going to be it. And does C match up with D? No, that doesn't work either. So that's out. And then if we look at this final one, this is the answer that we're looking for. It says that B matches up to C, right? And we know that's, B matches up to E here. I know that's a little different. And sure enough, it does. B and E match up. We talked about that. And C matches up to F. And that's true also. We talked about that as well. So the answer here is 4. This is the only one that has anything that actually makes sense. Okay, let's keep moving. Oh, man. 15. Ooh. Okay, so this has a circle with an inscribed quadrilateral, okay? So this is a level 9 question because it has to do with circles. So this is level 9. Circles. All right. And in this question, this is actually about inscribed quadrilaterals. And there was one fact we learned about these. Quadrilaterals. All right? And there's a fact that we learned about inscribed quadrilaterals, and that's this. Here's our fun fact. I'm about to write it down. Opposite angles are supplementary. All right? So if you were to look at this, I know that A and C are going to have supplementary angles, and I know that B and D will have supplementary angles. So since this is asking me for angle ADC, all right, ADC is right over here. over here, we just have to say that these two angles are going to be supplementary. So I'll just do 180 minus 72, and that gives me 108. Done and done. Easy question. Jeez, there's like a riot outside. What is going on out there? Sorry for the interference. All right, but anyway, big fact, opposite angles are supplementary. All right, we're going to keep moving. Keep moving, keep moving, keep moving. Whoa, okay. So this should look pretty familiar to you because we've actually been just doing this whole unit on volume. So this one says a hemispherical tank. Remember, that's just half a sphere. It's going to be half a sphere. All right, is filled with water and has a diameter of 10 feet. If water weighs 62.4 pounds per cubic foot, what is the total weight of the water tank? So we should know this. Weight is equal to the density times the volume. All right. Luckily, they gave us the density here, so we know that the density of water is 62.4 pounds per cubic foot, and now we just need the volume of the hemisphere, right? Well, we'll write down our volume formula, and remember, the Regents gives us this formula, 4/3 pi r to the third. All right. We know that our radius is equal to 5, which is half the diameter, and we're just going to put that into our calculator. When we do that, we get 523.59, and it just keeps going on from there. And we just put that in for our weight. For our volume. So we're just going to move this guy right over here. 523.59. Wait! No! I made a mistake. Did anyone catch that? Did anyone say, like, what's this guy doing? I forgot to do what? I forgot to divide that in 2. Oh, see how easily that could happen? It's a hemisphere. So we take that number, we divide that by 2, and that is the number that we want to put in for our volume. So it's 261.79, and you should all use the whole number, but I'm going to just leave it there. And when you multiply that by 62.4, you get number 1, approximately. Okay, oh, and guess what I forgot to put here? This is a level 10 question from 3D geometry. Okay, great. Okay, 2 more questions in this video, and then I'm going to have to end it off. Don't cry. It's just how things have to go sometimes. All right. Okay. All right. So, for this guy, for some reason, I can't erase all this stuff, so I'm just going to go like this. All right, for this guy, it tells us that triangle ABC is similar to ADE. So we know these 2 triangles are similar. And since we know those 2 triangles are similar and they're overlapping, you should do, as your first step, separate them. Whenever you have overlapping triangles, I've noticed that this so many times, you got to separate them. So this is a level 3 question. This is about similarity, and I've screened this so many times. But what we're going to do is start by separating the 2 triangles. We have a small triangle and we got a big triangle, right? And the small triangle has A, D, and E, and the big triangle has A, B, and C. And it says, which measurements are justified by similarity? And you might remember this. There's 2 facts about similar triangles we need to know. I'll put them down. One is that the ratios of the corresponding sides, you're like, why does it keep saying this? Repetition helps, are the same, and the angle measures are the same. All right, but we're just going to look at this one. So we know the ratio of the corresponding sides have to be the same. So you just have to test these and see if the ratios are the same. So I'll do number 1, and then I'll give you the right answer. Okay, so number 1 has this. If you try AD is 3 and AB is 6, all right, that's a ratio of 2 to 1. So 6 over 3 gives us 2 over 1, all right, or just 2. Okay. And then we'll try the next ratio. It says 12 and 4. Well, if we do 12 divided by 4, we get 3. And that doesn't work because the ratios are not the same, right? It's a ratio of 2 and a ratio of 3. So let's get that out of there. Bye-bye. Peace. Now, let's try a different one. Let's try this. Number 4. All right, 4 is AD is 2, AB is 6, AE is 5, AC is 15. So if we divide 6 over 2, we get 3. And if we do 15 divided by 5, we get 3. Look at that. The ratios are the same. This triangle is 3 times as large, so our answer is number 4. Bada bing. Okay, for our last problem, of this video at least, we're going to do number 18, and this is a really tricky one, okay? And I'll show you what makes it so tricky. And this one says triangle FGH is inscribed in circle O. The length of radius OH is 6, and FH is congruent to OG. So I'll mark that over here. What is the area of the sector formed by angle FOH? So we're basically trying to find this whole area over here. All right. But the problem is we need the angle basically to be able to do that. Because you might remember this, the area of a sector, and we always write down our formulas, is equal to theta, which is the angle, over 360 times pi r squared. That's the area formula. All right, now we know the radius is 6 because we got it right here. But that's all we know. But, so how are we going to get the angle? We need the theta to fill this out. Right now, all we got is this. We got something over 360 times pi times 6 squared. Once we get that angle, we're good to go. And I'll tell you how to figure it out. This is why this is such a tricky question. Like, how do you get that angle? Well, it tells you that FH and OG are congruent. Now, OG is a radius, right? So we know OG is actually congruent to OH because that's also a radius. And we also know OG is congruent to FO because that's also a radius. So this triangle right here that we just found, well, guess what? That is what we call an equilateral triangle. 60, 60, 60. Ooh, very clever, right? Clever question. So what we just have to do is plug in the number 60 now to get our answer. Why is it not like, it's sometimes just like don't erase, I don't like you. Okay, so now that we know this is 60, we're just going to plug this in. And if you notice here, all the question answers here are in terms of pi. So we're not going to multiply by pi when we do this. So we get 60 over 360. That actually reduces to 1/6. Pi times 6 squared is 36. We multiply these together. We get the answer is equal to 6 pi. What a beautiful answer. And that's what we're putting in here. Mark it down, guys. All right, that's it for this video. Come on back for the final of the multiple choice. We're going to be doing questions 19 through 24. Peace out.